superposition of having different values, and therefore it suddenly is only one of the places, if it was the place you measured, among which it was in superposition. So something a bit strange, called sometimes the collapse of the wave function, that it jumps from being in a superposition of having many values to just have one. This is a rather mysterious thing to impose, and it is, I think, strictly speaking, in disagreement with the equations of motion formulation in quantum mechanics, which is the Schrödinger equation, which would say that it would develop on staying in some superposition. So it's a rather strange thing, and it has to do with this interference of the observer.
Yes.
But that is a mystery, and people have discussed that, and there are many other ways of seeing mysteries in quantum mechanics. There's, for instance, this famous double-slit experiment discussed by Einstein and Bohr and so on. So there are many mysteries in quantum mechanics. And but I think that, for instance, this measurement mystery, this is one thing about which I wrote one article where I wanted to say that our model with this imaginary action, which we have talked about, which has arranged future from time to time, that model might be helpful in giving some saying about this problem, and perhaps to some extent solving it. Because in our model, which selects this minimal imaginary part of action, history, as the main one, in normal conditions, where you don't have too many double-slit experiments and so, in usual, almost classical physics, then this model will select a unique history, namely the history with this minimum. And you would therefore, in a way, if you had a good enough computer, then you could calculate the whole future, whatever. And then you can ask, yes, but what if I had a quantum experiment sneaked in at some time, and that I measured this? If I should trust this Copenhagen-born interpretation that you get a probability distribution of the results of the measurement at the end of your experiment, then how could it be that you could already by the computer have calculated even the future, because it depends on this thing which is, according to quantum mechanics, given by a probability distribution? That would be a bit strange.
Yes.
But then, of course, the answer of our model would be that the outcome of this, in Copenhagen interpretation, only statistically understood thing, this is calculable and is determined by the future. Whether this measurement result gives for the future that you switch on big machines making Higgses or not. So you could do an experiment, which we are essentially proposing to the CERN community, that you make a quantum measurement and get a random result, and let this result decide whether LHC should be stopped or not. And this experiment would then, if you really gave it a small enough probability for, under normal born Copenhagen interpretation statistics, to a little probability only for stopping the machine, and it then after all did it if you did the experiment, then you would almost have proven that there is some theory like ours was true. So our model would have been confirmed if you do that.
Yes.
And if it was done by such a quantum experiment or if it was done by some card game, pulling a card by Director General, then it would be exceedingly convincing that our model was right if you did certain experiments. So we want to propose that one does some random number generator, preferably both by quantum mechanics and by card game or so, and then that be deciding for whether we should stop or restrict the LHC to only go at low energy or low intensity or so. So, and then we would say, if you give the normally expected probability for the machine being stopped or restricted to be very small, then if it happens, a miracle happened, and this was a miracle of our model or a similar model, it could almost not be reproduced by anything. So it would be a fantastic evidence for our model being true.
That's very interesting. If we just generally go into a little bit about, because we have been talking about history basically as a variable. We have been talking slightly about future and so forth as well. Now I want to ask you about time travel, a huge area and subject, obviously, but what can you say about that? Do you think that it will be possible? Is your model in any way in favor of time travel as a possibility? Tell us about it.
Yes, I'm not sure it really is so much in favor of time travel, but it is, of course, a usual story that if you can make wormholes or small deviations, funny topologies in the space-time of Einstein's general relativity, including gravity, then in such models you tend to have time-traveling situations. But I think there are good reasons to say that they are very, very hard to realize in usual experiments, and it is almost it is far beyond present technology and perhaps exceedingly unlikely to really get this kind of time travel. But I should perhaps say that our model with this imaginary action was to a large extent inspired from theoretically thinking of these time travel stories. So we were thinking of time travel stories, especially this last version with the imaginary part of the action. I had really some earlier versions of similar influence from future theories papers back. But the last version, which is this imaginary action, and this work with Masao Ninomiya in Kyoto and now in Okayama, this one was strongly inspired by considering these time travel possibilities when you have when you have wormholes or other strange space-time topologies in general relativity, and these time travels give rise to these famous grandmother paradox, that you go back in time and kill your own grandmother, or other versions of the similar contradictory stories being produced.
Yes.
And then Novikov, who happens to be at this institute here, he has long talked about how to solve these time travel problems if you have time travel. And these time travel problems can be solved, but the way is that almost some miraculous thing happens, so that you don't really come to this bad deed of killing your grandmother, but by some very clever arrangement, the whole gets consistent. And he has some examples about how you roll a ball into the time machine, and then it rolls back in time and comes to a crossroad which it has passed before, but now it has rolled back in time, and it can just hit itself and shoot it off. This is a little bit analogous to killing your grandmother, because If the ball shoots itself off the root, it doesn't come.